we're going to do textbook problem 223, graphically and then algebraically. We have a plane that's going to take off from rest. We know the acceleration. What we're looking for is the distance that it needs to go to get up to its takeoff speed. So we know it starts at a VI of 0, because that's how planes start, from rest. And it's going to take some amount of time, delta t, that we don't know, in order to get up to its takeoff speed vf, which is known. And we do know the acceleration here, which is the slope of that graph. So what we need to do is determine the takeoff distance. So we need the delta x, which will be the area under this triangle. So delta x will be 1/2 times delta t, which is the base of that triangle, times vf, which is the height of that triangle here. Now, delta t we don't know, but we do know a. And a is the slope of that line. The slope of that line is vf minus vi over delta t. The vi is 0, so that can go away. So in this case, our acceleration is vf over delta t, or the delta t is vf over a. I can sub that back into the previous expression. So 1/2 vf squared over a, or a little more simply vf squared over a, so over 2a. And that's going to be 33 meters per second squared over 2 times 3 meters per second squared. Let's check the units. In the numerator I have meters squared per second squared. After I distribute the square, divided by meters per second squared, the per second squareds cancel, and then meters squared over meters is meters, which is what we expected. If vf increases, delta x will increase. If a increases, delta x will decrease. You'll need a shorter runway. And those are all what we'd expect. So if I calculate all that out, I get 181.5 meters. We're going to do this algebraically. Start with a diagram. VI of 0, VF 33 meters per second, which I'll call positive because I'll define positive to the right. My acceleration, therefore, is also to the right. It's speeding me up in that direction. That's the direction of my delta v. This displacement is unknown, but it does, well, the time as well is unknown. Okay, so the best model here, given the info we want, is this one that we developed in class. The VI goes away, so the delta x is VF squared over 2a, which is, again, 181.5 meters.